Good afternoon, everyone. How are you?
Good.
Hello. How's everybody?
Hello.
You guys okay? Did you eat your lunch already?
Yes.
Okay, good. Perfect. Okay, so let me see how many people we have here now. Okay, so we have now 26 students. We only need how many more? 13 more students so that we can have our class. Okay. I mean, we are going to complete the attendance, but it seems like we cannot complete the entire class before we're going to start. So let's just start right now and let's just wait for them later on. Okay. So welcome to our online learning prepared by foreign teachers in Patum Success 6, Anuban Chunbury School. This video recording is for educational purposes only. My name is Teacher Edward and I am your speaker for this afternoon. Okay, so last week we finished the unit 1 about health and nutrition. We studied different things, the 6 types of nutrients. What else? Can you still remember what are the things that we studied? 6 types of nutrients: carbohydrates, proteins, fats, vitamins, minerals, water. What else? We also study food pyramid, right? What else? If nobody will answer, we cannot proceed. Come on. Food pyramid, 6 types of nutrients. What else? Come on, 6/1. What else did we study for chapter 1? What about BMI? Yes or no? What are the 4 weight categories of BMI?
Underweight,
Mm-hmm.
normal weight, overweight, and obese.
Okay, so that's it. So we have food pyramid, 6 types of nutrients, BMI. What else? What else can you remember in our lesson?
Food preservative.
Mm-hmm. Food preservatives, food additives, yeah, food additives, preservatives, and food coloring. Okay, what else? We study also how to take. We study before the how to take care. We study the digestive system, right? Like mouth, esophagus, stomach, small intestine, large intestine, rectum, anus, gallbladder, liver, and pancreas, right? And also we study about what else? How to take care of our digestive system, right? Can you tell me what are the ways how can we take care of our digestive system?
Wash our hands.
Washing our hands, exercise, what else?
Chew our food.
Chewing our food more, what else?
Use the food that cooking fully.
Okay, cook food fully. There are many items I shared to you, right? Eat a high fiber diet. And you need to select lean meats. Okay, and I think last week, if you can still remember, we discussed about the introduction to, what is that? We make a juice and we blended some fruits and vegetables, right? So those are ways also how can we keep our digestive system healthy. All right. So, and yeah, last week we also had our unit test. So since we had our unit test, we cannot go back. It means it's already finished in chapter 1. So I think we are going to end our first semester, I think we will be able to have a unit test also in hopefully in the next unit or the next chapter, which is all about matter. Okay, so here there are like 3 states of matter, as we all know already: solid, liquid, gas, and processes involved in the 3 states of matter, properties of each matter, and physical and chemical change. All right, so this is a little bit this is quite an introduction for chapter 2. It was not included in your book, so you can put your book somewhere, because we will not be using it for now. Okay, but if you have your notebook, please copy something, because we will do something. We will answer some questions today, and then tomorrow I will make it into a Google form. Okay, yeah. All right, so let's begin. Can you still remember what are the 3 states of matter?
Solid, liquid, and gas.
Okay, so we have 3 states of matter, but there are not limited to only 3. There are actually 4, as some says 5.
Plasma.
Yes, plasma is number 4. So number 1 here is the first of the vocabulary words is the word property. Okay, I want you to read it with me as well. Let's read it all together. 1, 2, 3.
Property.
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 Okay, let's read it again. It seems like there are only 2 students in 6/1. Number 1, property.
Property.
Very good. Number 2, compact.
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 Number 3, molecules.
Molecule.
Number 4, pressure.
Pressure.
Number 5, particles.
Particles.
Number 6, rigid.
Rigid.
Number 7, definite.
Definitely.
Number 8, melt.
Melt.
Okay, thank you. All right, so where is this? What is this? Okay. So for a warm-up video, let's watch this video. It's very short, and I hope it will help you remember this lesson.
All right, everybody, are you ready for the 3 states of matter song? Here we go. Solid, liquid, and gas. The 3 states of matter, they all have mass. Solid, liquid, and gas, they all have mass. Oh yeah. A solid is firm, a solid is hard. Just like the rocks in your backyard. A liquid is wobbly, a liquid is loose. Just like water or milk or juice. A gas is the trickiest one to me, because a gas is something that you cannot see. The helium gas in your balloon makes it float all around the room. Come on! Solid, liquid, and gas. The 3 states of matter, they all have mass. Solid, liquid, and gas, they all have mass. One more time, you guys, come on. Solid, liquid, and gas. The 3 states of matter, they all have mass. Solid, liquid, and gas, they all have mass. All right.
All right, so yeah, it's all about the solid, liquid, gas, and I'm sure that you pretty much remember the lesson. Okay, now let's proceed to, oops, where is this? Okay, so the first word here is the word property. Okay, may I request Wacharawit? Can you hear me, Wacharawit? Wacharawit, number 34, can you hear me? Okay. Panatat, can you hear me?
Yes.
Okay, can you read Panatat, the meaning of property, please? Panatat, can you read, please?
An attribute, quantity, or characteristic of something.
Thank you. An attribute, it's not, it is pronounced as attribute, quality or characteristic of something, like the one you see in the picture. It is like an oil, right? What is this? The oil is like flowing, okay? So different materials like water or different matter like wood, metal, plastic have different properties, okay? So different things have different properties. The next word here is compact. May I request this one? Can you hear me? This one? Please read this one, please.
I think this microphone is at work. It's already.
Okay. Okay, so this one's microphone is not working. What about number 26? Number 26. Can you read the word compact, please? Who is this number 26? Tanpisit. Okay, Tanpisit, can you read this one? Can you read the definition of compact, please? Tanpisit. Hello, Tanpisit, can you hear me? Nah, can't hear. So let's ask Natcha. Number 36. Can you hear me? Number 36.
Yes.
Can you read compact, please? Please read the meaning.
Closely and neatly packed together.
Okay, closely and neatly packed together or dense. It can be like a cell phone. Okay, like for example, a cell phone is very compact. Okay, this is an example of a very compact object. Okay, so they put a lot of things inside. It means it's very, very, very compact. Okay, it can be a laptop. Okay, so if they want to make the laptop smaller, they need to put things, everything together inside in a very compact manner. All right, now let's proceed to the next word. Molecules. May I request Patarida? Can you hear me, Patarida? Patarida? I think Patarida is not here. What about Suwapich? Are you here? Suwapich?
Yeah.
Can you read, please, the meaning of molecules? Go.
A group of atoms bond together, representing the smallest fundamental unit of a chemical compound that can take a part in a chemical.
Thank you. Thank you. So this is a molecule. A molecule is a chemical compound like this one, the one you can see. What do you think is this molecules? This is a molecules of what?
Water.
Yeah, it's water. So how many hydrogen can you see in the picture?
2.
Yeah, because it's H2O, right? So
Yeah.
and we all have one oxygen. Yeah. So the big one is the oxygen and these two are hydrogen. So they are connected in a bond together. All right. So that is a molecule. The next word here is pressure. May I request Purama to read? Purama, can you read, please?
Yes.
Go.
Pressure, continue physical force exerted on or against an object by something in contact with it.
Thank you. So a pressure, as what you can see in the video, in the picture, is that when you continuously exert a force like this, okay, then it will create a pressure, okay, like the one you see in the with a softball. It is getting how do you describe this? Getting pummeled, or yeah, because of too much pressure. All right. So the next word here, yeah, also this word is very, very important for you to understand, because in the lesson about rocks, right? You still remember rocks?
Yes.
There is like the heat and pressure. See? So here in unit 2, I introduced to you already the word pressure. All right. So there. Now let's proceed to the next word here, particles. May I request Parami number 16 for please read the meaning of particles. Am I mute? Go. I think Parami is not here. What about who is this? Pungnarit? Can you read this one? Pungnarit, please. Particles. Am I mute? Go. Pungnarit is not here also. What about what? Charawit? Can you? Okay. Pungnarit, go. Can you read? A minute portion, go.
A minute portion of matter.
Okay, so the meaning of the word minute, it is a very, very small. It means a very, very small portion of matter. So it can be like the PM 2.5. Okay, so that is a particles. It is a very, very, very small. But when there's a lot of particles in the air, when there's a lot of particles in the air, then you can inhale it, then it will make you sick. It will damage your lungs, because as what we've studied in our health lesson, that we inhale, right? We take in oxygen. Now imagine if there's a lot of particles that will go inside your nose here, and it will go to your lungs. So eventually you will be sick. That is why the people, even if there's no COVID-19, and they are living in a place like it is very polluted, now have air pollution, they need to wear masks. See? Because if they can inhale the big particles, it can damage their body, especially their lungs. So it's not good. All right, and the next word here is rigid. Okay, meaning of the word rigid is unable to bend or forced out of shape, not flexible. See this one? This tent is for sure not rigid. Not rigid. The tent is not rigid, or the frame of the tent is not rigid, because it was blown away by the wind. Now I would like to explain a little bit about this word. Can you tell me what are the part of your body that is you can consider rigid? Can you tell me part of your body that is rigid?
Maybe bone.
I'm sorry?
Maybe bone.
Yes, our bones. Our bones are rigid. That's why, like, look at my hands. Yeah, you can see my hands, right? You can see it. This one right here, we have joints. That's why we can move it. But this part right here, the bone from here going here to the elbow, it means it is not rigid. This part right here, they are not rigid. So when there is a force something, it will be broken because it cannot be bent. It is what is this? Not flexible. Okay. Only the joints are flexible. Okay, so the next word here is definite. May I request somebody to read this one? Dun Raporn, please.
Clearly straight or decided, not vague or doubtful.
I will read again because there are words that you mispronounce. Clearly stated. Okay, so clearly stated, for example, the instruction. For example, write letter T if the statement is true, and write letter F if the statement is false. So that is the instruction. It should be clearly stated or decided. Okay, not vague. Okay, the pronunciation of that word is vague. Not vague or doubtful. It means not sure. No, it should be sure. Okay, we don't like it to be not sure. Like the one here, the one you can see in the picture, this is the starting line. Okay, so this is the starting line. That is the definite starting line. We can see it. Okay, we can see that you need to start. Okay, there on that definite or that starting line. Nobody can go ahead of the starting line. All right, so that is the meaning of the word definite. Now, the last word here is, I think this is the last word. May I request number 20? Techit, number 20. Can you read the melt, please? Number 20. Oh, I think number 20 is still sleeping, or I don't know what happened. What about number 30? Number 32? Are you here, number 32?
Yes.
Can you read, please, the meaning of the word melt?
Make or become liquid by heat.
Okay, I will read again. Make or become liquefied. Liquefied means it will become liquid. Or we have also the word solidified. Okay, so solidified means it will become solid. In this case, it will become liquefied. Liquefied means it will become a liquid. Okay, to make something becomes liquid. That is the meaning of the word melt. So what are the things that can melt? Can you tell me of an example of a word that can melt?
Ice.
Ice. What else? Only ice?
Chocolate.
Okay, very good.
Bomb.
Chocolate. Yeah. What else? What else? What are the things that can melt? What is that, Jirayu?
Butter.
Butter. Yeah. What else? What about our
Ice cream.
Oh, ice cream. Yeah, sure, ice cream. Ice cream can melt. What else? Why you keep on answering all the, what is this, foods? And the foods that I like. I'm becoming hungry. Well, what else? What else? What about rocks? Can a rock melt?
Yes.
Yeah, rocks can be melt also. What about plastic? Can the plastic be
Yeah,
melt?
it melts
Yeah?
by heat.
Yeah, what about metal?
Yeah.
What else? What else can we can melt? I think there's a lot of things we can melt. Yeah, I think so. There's a lot of things. Thank you for your answer. So now we are going to proceed to our quiz time. All right. So are you ready now for our quiz time? Of course, this is fill in the blanks. There are words here that you will be using in order for us to answer all the questions here. Or maybe do you want me to cover the answers here? Because this is 6/1. Maybe
No.
you You already know the answer, right? So maybe I will put something here. Do you want me to cover the answer? Do you want me to cover the answer?
No.
What? I think Jira, you said cover. Tama? Cover or not?
No.
Okay, see? See, Jira, you said no, I don't want to see. That's what Jira, you said. No, I don't want to see the answer. I will just answer by myself. What's your answer? Yes or no, Jirayu?
Yes.
Oh, see, yes, to cover. See?
No.
No, yeah. Yes, I want you to cover. I don't want to see. No. See? Yes and no. So we're going to cover now. Or maybe I will just open this for you. Maybe we will take some time. Okay. Oops. All right, there. Okay. So yeah, you're happy now. So number one is an example. We need to melt 2 ounces of butter. So this is the answer of Jirayu. The butter can be melted. Melt. What about number 2? All the runners need a blank starting point so that no one has an unfair advantage. What's your answer?
Definite.
Definite. So Nataya lost the ability to answer again because she already used her power to answer. Okay, so we will be waiting for other students to answer the following or the next questions. All right. So number 3, we need a blank support frame for our tent. What should be the answer? We need a blank support frame for our tent. Nataya cannot answer anymore because she already finished answering the definite. Right? So it should be someone else to answer. Okay. Parinya, Chuntida, or yeah, I think Parinya has an answer. What's your answer, sir?
Rigid.
Rigid. Very good. Perfect. Rigid. We need a rigid support frame for our tent. And the number 4 was unmasked. You can see the answer already. So I will just read. The property of water is totally different from a helium gas. Okay. What about number 5? Let's ask here. Very good friend, Putisan, to answer the next question. The notebook computer is very small and blank and weighs only 1.6 kilograms. What's your answer? What is your answer? So
Pressure.
Okay, I will just mark everything here because all the answers here were taken, right? So your answer is pressure. Oh, you want the pressure for your notebook computer? Nah, pressure is the wrong answer. Sorry. What about Satawit? My very quiet friend, but always answer correct. Satawit, what do you think is your answer here for number 5?
Compact.
Compact. Very good. Yeah, the answer is compact. The notebook computer is small and compact and weighs only 1.6 kilograms. So here, they just put something like this. Okay, like they put a lot of things there. Okay. We can use blank to control the bleeding. So what is the answer here? For example, yeah, Faraday, what's your answer?
Pressure.
Okay, yeah, we can use or we can apply pressure to control the bleeding. Okay, so if somebody was shot or have some injury and the blood is coming out, so you need to apply pressure, no, Chuntida, so that the blood will not come out anymore. All right. So that is there. The word is pressure. Okay. Number 8. Who wants to answer number 8? Maybe I will ask Napichaya. What's your answer for number 7? Not number 8, number 7.
Molecule.
Tiny molecules in the air can damage our lungs. Na? Molecules or particles? Napichaya. Napichaya? What do you think is the best answer? Molecules or particles?
Particle.
Very good. Tiny particles in the air, like PM 2.5, can damage our lungs. Because if we talk about molecules, it talks about the oxygen, what is this? Hydrogen, helium. Okay, those are the molecules. All right, like the molecules in the water, H2O. Those are molecules. But if we talk about these tiny particles, okay, tiny matters in the air can damage our lungs. It is referring to a particle. All right. So thank you everybody for answering our very simple quiz. I will give you 5 seconds to take a picture of this, or if you want to copy on your notebook so that you can answer the quiz perfectly next time. All right. Where's my water? All right, that's more than 5 seconds already. Okay, so now we are going to proceed to the next. Oh, sorry, you didn't see the answer? Yeah, up there. Okay, take a picture now or print screen or whatever you want to do. Okay, so the next word here or the next slide will be all about our topic now. So since we finished this already, maybe no, we will not go to it one by one. So I think I told you to copy this thing in your notebook, right? Do you have your notebook with you? What is the meaning of matter again? Do you have your notebook? Can you read the meaning of notebook? Oh, the meaning of notebook. The meaning of matter that I let you copy last time. Do you have it with you? Your notebook? Do you have a meaning there? Do you have the definition of matter? Mime?
Matter is everything around you. Matter is definite as anything that has mass and take up space.
All right, perfect. Good, good. So in simple term or in one sentence, here, matter is anything that has mass and takes up space. So what is mass? The problem now is what is mass? And what is the meaning of takes up space? Takes up space is another term for volume. Okay. Okay. So that is the very, very first meaning that I memorized when I was in elementary or in Pratum. Maybe, I don't know, Pratum 3 or 4, I don't know. But our teacher told us, you need to memorize the definition of matter. Matter is anything that has mass and takes up space. All right. So in order for us to make it shorter, we can just say matter is anything that has mass and volume. It has mass and volume. All right. So matter is anything that has mass and volume because takes up space means the volume. All right. So let's now proceed here to the next slide. What are matters? Example of matters again? This one is what is this? The clouds, right? Gas. This one is the water. symbolizes the liquid, and this one mountain to highlight the solid. So basically it is these are the three states of matter: solid, liquid, and gas. Okay, which our earth is made up of. Okay, now let's study what is mass. Okay, which one has a greater mass, the balloon or the statue? Basically, the balloon is bigger. This is a very, very big balloon, but the one in the picture is not very big. So basically, if you're going to compare this one, the statue here, the one that is this one is a very small statue. It's very small, and the balloon on the other side is big. But the question is, which of the following has a lot of mass? The balloon or the statue? Which of the following has a lot or plenty of mass?
Statue, okay.
Yes, it is the statue. It doesn't mean that the balloon is big, then it means the mass is higher also. So here, you might have, it says here, you might have, what is this? A large object with a very little mass, okay, very little mass, such as a balloon. So balloon has a very little mass. Okay, and there are also things that very, very small objects, okay, like a statue, but have a lot of mass. Okay, so those are the things that you need to remember in mass. Now, what is the difference between mass and weight? Are they the same? Are they the same? Anybody can answer? Is the mass and the weight the same?
No.
No, right? They are not the same. Because here, the mass is the measure of the matter of an object. So it means like, how can I explain this? How can I explain the mass? How can I explain the mass to you in a simple term that you will be amazed? Maybe a video will be able to help you. Maybe, okay, maybe video will be able to help you. And since this is just a review because we finished this already, let us take some time in answering or looking some videos here. Adding no, not this one, not the marble. They don't have it here, but I saw something in the, or maybe adding, wait. This one, yeah. Then look at this.
ใช้เทพไทย
And let's see, what is this? Is this a mass? Or at the end, let's say if this is a mass or a weight. Okay, oh my God, the advertisements. Okay, there, good.
Okay, today we're going to be seeing how close you can get to a drop of a neutron star. So before we can test this, let's talk about what a neutron star actually is. So you have normal stars like our sun, and our sun has a lot of mass. And when you have a lot of mass, mass has gravity and it wants to compress together and it wants to attract each other and compress tighter and tighter together.
So see, he explained there, the mass attracts the weight and the things around it.
But the reason our sun doesn't just collapse in on itself is because there's another force that's pushing it apart. And that force is due to the explosion that's constantly happening in the sun due to nuclear fusion. So hydrogen is constantly forming into helium and it's exploding the sun. So this exploding force is pushing it out and gravity is pushing it in more and more together. But what can happen sometimes is if there's enough mass, then the mass will keep collapsing in on itself in the star and it'll collapse more and more and more and more until actual electrons are becoming so close together that they become as close together as they can possibly get, and the only thing that's stopping them from overlapping each other is the Polyexclusion Principle. And the Polyexclusion Principle says that you can't have two electrons in the same place at the same time. And
I will forward a little bit because he's explaining a lot of things. Okay, so basically what he's holding here is a very small, is this a cube or circle? Cube, right? Yeah, it's a cube. So let's see.
Neutron star and see what happens. So to start off, let me show you what it looks like. So I have a cube here just at normal Earth density.
So it means like this is a normal weight density. So the density of lead here on Earth is like 11,000 kilograms. Oh, what is this? Yeah. Cubic
Put it on
meter.
there. It weighs around only 5 grams. Now I'm gonna do my magic touch on this cube. So now this is getting really heavy for the size of it.
Look at
now
that.
You can see how heavy it is. Put it in there. Weighs 50 grams instead.
So it changed the weight, right? It changed.
Instead of 5. Okay, now let's increase the density even more. And go. Whoa. Holy cow.
Oh my God, this thing will be broken. This thing will be broken because he keeps on adding the density of this thing. See? Yeah, I told you.
Broke my thing. Dang it. Broke through my jar. It got so heavy. Holy cow. So you can see it's extremely heavy now for the size of it.
See, he cannot even lift it up because of its too much density. It means it's very, very heavy already.
Barely pick it up. Oh.
My God.
Look at that. Ow. So I would say this weighs around 1 pound now. You can see how heavy it is here. Ow. Okay, I'm increasing the density. I can't even hold it.
So he tried to add the density again?
Anymore.
The mass?
Oh, it went through the table.
It broke through the table. It is because it's very heavy already. But as you can see, it didn't change the size. Oh.
Okay, so we're gonna need a stronger base, but let's just go ahead and turn it all the way up to Neutron Star and see what happens. 3, 2, 1. Whoa, it just shot through the Earth.
Nah, it goes down. It's it's very much, what is this? Too heavy.
So right now it's basically vaporizing the mantle in front of it and leaving a trail of hot plasma behind it. In a while, as it falls, it'll eventually just become lodged in the Earth's core. So let's try this again with a holder that will actually stop it from falling through the table and through the Earth. Okay, now let's redo this experiment with a magic stand that can support the weight of the 100 billion kilograms in that tiny little centimeter cube there.
So see, even in a very, very small thing, you can make it like, what does he say? 100 of thousands of kilograms.
Now, because this is so dense, it has its own gravity force that I can feel. And what this feels like to me is that when I start to walk closer to it, it kind of feels like I'm starting to walk down a steep downhill because the gravity is pulling me towards the neutron star instead of straight down towards the Earth. So I kind of feel like I'm walking down a hill. So even just sitting next to it on a table, it's like gravity is pointing that way towards the drop of the neutron star instead of straight down towards the Earth. Whoa. Okay, now because gravity is proportional to the square of distance, it becomes increasingly hard to pull away from the neutron star drop the closer you get to it. So if you get closer than a critical distance, then you won't be able to get away from it ever. So that means that if I want to touch this neutron star drop, I'm going to need another plan. And that plan has to do with water. Okay, so I managed to get some water around this. And if I didn't have this box around it, it would look like this. It would be a complete sphere around it with the drop at the very center, because gravity is now pulling it all towards.
Wow, look at this. If the neutron ball, or whatever it is he called it, it will, if there is no container, the water will form a ball like this. Wow, it's very interesting.
Towards the center. Now, normally the point of no return with a drop this size of a neutron star is around 8 inches. Around 8 inches away, your arm would become too heavy to ever pull back, and then it would just get sucked in and probably get ripped off, and it would pull your whole body in and you'd compress down into the neutron star. But if you put water around it, something interesting happens. So let's see if this orange gets sucked in. Huh. It just floats. So at this range, it's hundreds of times of Earth's gravity, but it's floating on top here. So that means that buoyancy has nothing to do with the strength of gravity. And the reason it works like this is because the neutron star drop is pulling on the water just as much as it's pulling on the orange. But it pulls on the water a little more because the water is a little more dense. So the orange still floats on top of the water. So this means on different planets, whether it had stronger or weaker gravity than Earth, boats would still be able to float just fine. They'd have the same buoyancy as on Earth, because buoyancy is independent of the gravitational factor. So that means my hand should be.
So it means that the gravity, for example, the different planets have different gravity, but the law of buoyancy, like this one, the orange is still floating, means it is not affected by gravity. There's a lot of things we can learn from here, but I think it's too much for you now, for me to explain all of those. But I hope you find that video interesting. You can watch it again. Okay, so here, that is the difference between mass and weight. The weight is just a measure of gravity's pull. Okay, so the mass is the measure of the matter in an object, and while weight is a measure of the gravity's pull on an object. All right, so volume, the next word, because we focus on the mass and the volume, right? So the volume here is the amount of space something occupies. And there are words that we use, very simple words that we use to describe volume. What are those words? Big, a little, long, short. Okay, so these words are used to describe the volumes. Okay, like I saw a very big cat. Okay, so that is a big means it describes a volume of an object. Little, long, or short. Okay, so that is the volume of an object. Okay, how big it is. For example, Teacher Edward has a very big face. So yeah, that is the volume. Okay, so if there's a mass and there's a volume, then it is a matter. Okay, what time is it? Let's do it quickly. We're running out of time. Okay, so we have here solid. Solid is a very rigid. It means you cannot bend it. Like I mean, you can. I think you can bend it like a metal.
Yeah.
If it is a little bit soft, you can bend. But this is like relatively rigid compared to other phase. So it has a definite volume and the shape. Of course, this one is a solid state, like a cell phone. This is solid, so we can see that the shape doesn't change, right? The shape doesn't change. And the volume is fixed. Okay, the volume is like this. It will not change. Okay, and the molecules are attached to each other. They move, they vibrate in place, but they don't move around. Okay, so they vibrate in each other, but they don't move around. That is solid. Next one here, oops, go back. The next one here is the liquid. Okay, so the liquid, on the other hand, can move. Okay, but they are also together. So when one molecule go there, all of them will go there. So that is the water. Okay, the liquid. They can move Unlike solid, they can move, but they are attached to each other. Okay, they are attached to each other. When somebody will go there, everybody will go there. All the molecules will go there. They are close together. Okay, unlike the gas. And here also, one thing is very amazing about the liquids is that this is the only phase of matter where it takes in the shape of its container. Okay, if you put the water or oil in the square container, then the water will shape like will follow the shape of its container. Square also, if you put it in a heart, it will become heart as well. A star or whatever shape you want, then the water will do as well. Okay, and gas, on the other hand, it has no definite volume. Okay, so what is the volume again? What are the words that we can use to describe volume? Big, small, long, and short. Can you say like, oh, the wind, or the wind is very long? Can you say like that? Oh, the wind is very big. See, we cannot. Yeah, we cannot say that because it has no what? No volume, no definite volume, right? And it has no definite shape. And atoms and molecules are spread apart. It means they are free to go anywhere. Some of the air will go to the house of Teacher Edward. Some of the air will go to the house of Paradi. Some will go to the house of Juntida. Everywhere, they are free to go. Now the question is fire. Do you know what is a fire?
Yeah.
Is a fire a solid, liquid, or gas?
Gas.
What is a solid, liquid, or gas? Fire.
I think gas.
You think it's gas. Okay. What else? The flame, no? We're talking about the flame. Okay. So that is actually the plasma, the lightning, the, what is this? Aurora borealis. Do you know what is an aurora borealis? Maybe we can take a look at this. This is what we call the northern light. Northern lights. See there. See, you can see there. Oh, very nice color.
We have it in the Zoom background.
In the Zoom background, yeah, we have it in the Zoom background. Yeah, so this is the northern lights, or also called the aurora borealis, and it is considered as the fourth, what is this? Fourth state of matter, plasma. So if you want to watch this video, you can see what is plasma. Like the, yeah. So there, that is the fourth state of matter. So it is like a gas, but it is not a gas. Okay, it has different properties from an ordinary gas. So plasmas occur naturally in flames, lightning, and auroras, the one I show you, like aurora borealis. Okay, so let's now proceed here. Each of these states is also known as a phase. So we have a solid phase, liquid phase, gas phase, or plasma phase, right? And the thing, what is cool about this is that when we change the temperature, if we try to make it very, very cold, or sometimes we put it like apply too much temperature, or the temperature goes up higher and higher, then there are some changes that will happen to these states of matter, right? So the first example here is this physical change. Can you explain? Somebody explain to me what can you see in this picture right there inside the box? Paradi, can you explain to me what is happening here in this red box?
I think it's freezing.
Yeah. What happened to the water? It becomes
Ice.
Yeah. Okay, so that is physical change, no? The water becomes ice. That is the physical change. It is the same thing. It is still water. Now, what about the second picture here? Maybe who wants to explain this? This is very simple, right? Maybe Nataya wants to explain. No? Yeah. I think you can. What is this? What is this? What is wait. Let me check. Wait, let me do something. What do you think is this? Yeah. What are these things?
Yeah, water molecules.
These are water molecules, right? So it's put here the H2O. Tama? H2O. All right. And what about this? What about this? What? How many hydrogen you can see?
Nah, 2.
2. And how many oxygen? How many oxygen you can see?
1.
Huh? How many oxygen you can see?
1.
Oxygen 1, hydrogen
1 lah.
2.
2.
Yeah. So it is it should be H2O2. Okay. Yeah, everything is here. So this is what we called hydrogen peroxide. So what happened here in the hydrogen peroxide is that, yeah, here, this is a hydrogen peroxide or the H2O2. And what is this? If you could add second oxygen atom to water. Now, if you add extra oxygen to the water, you would have hydrogen peroxide. Okay? The molecules would not be water anymore because you change it into hydrogen peroxide. So are they the same? Is this the same with this? No, they are not the same anymore, but because the first one here, the water and ice, the same water, they're the same water. But this thing here, this and this are not the same. So that is what we called a physical and chemical change. Can you give me an example of a physical and chemical change of, let's say, a paper? Can you explain to me by using a paper, what is the physical change and chemical change of paper? How can we change the paper physically?
Fold it.
You fold it. Okay, what else? What are other ways to make it physically change? Fold, what else?
Write.
Right?
Write on it.
Write on it? I think writing on it. Okay, okay, I will consider. Cutting, what about cutting the paper? Is that physical change?
Yeah.
Yeah, if I cut the paper, what if I will tear the paper? I will tear the paper. That is also physical change, right? Now, what about Chuntira? How can we make the paper undergo chemical change? Anybody? Burn it. Very good. If we burn the paper, it will no longer be a paper. It will become an ash or ashes, right? It will become an ashes. So they are not paper again or anymore. It is changed to a new substance. So that is chemical change. Like the rock, we study rocks, and there are like chemical change also in the rocks. Like for example, the what is that? Sediments together, combined together. That is like we can say it is a physical change, but when there is a heat and pressure, it will become a metamorphic rock. Then it undergoes a chemical change. See, that is a chemical and physical change. All right. So yeah, these are the things that we study already. And maybe you missed this video. This is the video of sublimation. What is this again?
Iodine.
Iodine. And what happened here? Iodine becomes solid. It becomes?
Gas.
Gas. Okay, so that is the sublimation and deposition. If you want to study that one, this is the spelling, sublimation and deposition. Okay, since we don't have time, boys and girls, I will just check your attendance and then I'll be seeing you again maybe next year. Oh no, I'll be seeing you again on Wednesday. I'll be seeing you again on Wednesday. Wait. So I will delete this. Yeah, because it is now October. So clear contents, and today is Monday. Wait. Oh my. I will just copy. Okay. So this is, it will take only like few minutes, okay? Just bear with me. I will just check your attendance. All right. So here, let's see who's absent today. Only 33 students. So let's check. 1, 2, 3, 4, 5, 6. Number 7, are you here? So Pakrit was here. 8, 9, 10, 11, 12, 13, 14. Number 14, Apiwit is absent. Okay, 14. And then 15, 16, 17, 18, 19, 20. 21, is number 21 here? Noparad was here. And Lalada also, but I don't know what happened. They left early. 23, 24, 25. So a pitch was here. 26, 27. Jirapat. Did you see Jirapat today? Nah. 29. Okay, this one was here. 31, 32, 33, 34, 35, 36, 37, 38, 39. Okay, so that's it. So let's take a picture, everybody, and we're going to finish our class now. Turn on your camera, please, so that we can take a picture together. Do not forget to drink your water, and then yeah, we can end our class now. Video, where's your video? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Smile. Oh. Okay, finished already. Goodbye, everybody. Oh, before I forget, did you watch my video in health?
Yes.
If you watch the video on health, at the end of that, I gave you an homework. And what is that homework?
Family tree.
Family tree. Where are you going to put it?
A4 paper.
A4 paper, very good. So I already made an album there. You put it there. Or maybe I will make a quiz also for health. Do you want a quiz for health?
No.
Yes, yes, so we will have. Okay, goodbye everyone. I will end now.
Thank you, teacher.
Thank you also.